of creating sound. So let me divide this up into three kind of columns here. The first way we're going to look at is the type we've been talking about, strings. Okay? Strings. In order for a string to make noise, it has to be under tension. I don't know if you've ever tried plucking a guitar string when it's not attached to a guitar, but it doesn't work too well. So in order for a string to make a sound, it has to be under tension. So here's the normal string. Okay? And when a string is plucked, it's going to move up and down like this. Up and down like this. Now, if you'll notice, this right here is not an entire wavelength. Okay? Let's say the string is a length L long. This is only half of a wavelength. If you don't believe me, here's an entire wavelength. Remember, it's up and down, a complete cycle. But this is what we have on our string, only half of it. So for strings, we got this nice little equation. The length equals only half of the wavelength lambda. Okay, so keep that in mind. The length only equals half of the wavelength. The next type of music producing object we're going to look at is a column of air. A column of air. Okay? And actually both of these are going to be columns of air. Okay, but with one key difference. For this column, this is going to be like, is it a flute? Is a flute open at both ends? Yeah. We're going to look at a column of air that's open at both ends. Okay? A column of air that's open at both ends. So open at both ends. Okay? Well, here's the thing about an open end. An open end acts like, let me see if I can go back and keep my notes. Yes, good, I can. An open end acts like this guy right here. Okay? It acts like a free end, or open. So this guy, the fixed end, had to be a node. So the open end over here has to be an antinode. Okay? Both of these have to be antinodes. Well, if you look, the smallest amount of wave, okay, here's my wave. The smallest amount of wave that I can fit in this column of air with two antinodes is right here. Okay? So the standing wave in this open column of air will look something like this. Oh, it's tough to draw. Oh, it's tough to draw. Oh, I did a crappy job. Okay, anyway. So you have an antinode on one end, an antinode on the other end, and a node here in the middle. Node here in the middle. Okay? So if you look, I've essentially divided my wave up into fourths. Right? 1, 2, 3, 4. And the amount of wave that is in this open column is, again, half from here to here. It's section 2 and section 3. I've left off 1 and 4. So once again, if this column is length L long, we have L equals 1/2 lambda. That's for a column of air that's open at both ends. Okay? And, as it turns out, this also works if the column of air is closed at both ends. A closed end has to act like a fixed end. So we have to have a node here and a node here, just like the string. Node and node. So we get this action going once again, which we know how to calculate already. L equals 1/2 lambda. Okay? So really this should be closed or open at both ends, so long as both of the ends match. Alright? So by process of elimination, this guy has got to be mismatched. Okay? Mismatched ends. Closed at one end, open at the other. Okay? So this is a column of air that's closed at one end, open at the other. What's a good example of this?
Blowing in a Coke bottle.
Ah, yes. Blowing a Coke bottle. Aren't oboes like this, I want to say? maybe not.
Oboes would be you blow in one end and it comes at the other.
So,
So,
yeah. Okay, so column of air that's closed at one end, open at the other. Well, remember, closed ends have to be nodes, open ends have to be antinodes. All right? Well, looking at my wave back over here in this column, let's see. Here's a node, okay? The closest antinode is right here. That's actually only a quarter of the wave. From right here, just like that. That's only 1/4 of the wave. So we have L equals, if this is length L, 1/4 lambda. Okay? So, we get some very, very tricky problems with these columns of air. Okay? Usually what will happen is they'll ask you what is the, a column of air is so long. Okay, and in fact, let's do a quick little problem, real quick. Which one do you want to do, the closed or the open?
Let's do the open.
Okay, both open or one closed and one open?
Let's do both open.
Both open. Okay, so let's have a column of air that's open on both ends. Okay, and let's make it, I don't know, 4 meters long. Okay, column of air, 4 meters long, open on both ends. Okay, what is the frequency of note that's played? Okay, that's all the info you get. What is the note? Well, to do this, you have to know what's actually producing the sound. The air itself is producing the sound. So we're going to use this relationship right here, V equals F lambda. Okay, you should remember this from your notes. The velocity is going to be the velocity of sound in air, 343 meters per second. Sometimes it's 344, sometimes it's 333. Okay, so 343 meters per second is our V. Our frequency is what we want, and the wavelength, here's where we have to be careful. It's open at both ends, so the total length equals only half the wavelength. The total length is 4 equals 1/2 lambda. So we can see lambda is 8. Okay, so we do the math and we get a number. I don't know. What is it? And you can do it. Okay, so that's pretty much all I got. Can you think of anything else they need?
No, I can't.
Okay, we'll cover this more in depth in class on Monday, of course. But for now, this should be a good start to get you on your way on Quest. Be careful about fundamentals and harmonics. We haven't quite covered that yet. So if they're just asking for frequency, you can go ahead and try it. If they're asking for fundamentals or harmonics, hold off until Monday.